Okay, so now we're talking about how to apply Leslie matrices in terms of the recurrence relation and the rule. So remember, the recurrence relation is how we find the next number in the sequence. The rule is how we jump to a particular point in time. So we need to learn both parts. Remember, the recurrence relationship has two parts, and it is finding the next number in the sequence. I want you to be really clear on keeping those two things separate and understanding the difference. They work the same way as they do for the transition matrices. So if we know how many female lizards there are in a colony for each age group, we can create an initial state matrix and then find the number of female lizards in each age group after 1 year by multiplying the Leslie matrix on the left. So the Leslie matrix is really a specific type of transition matrix if you want to overly simplify it without a definition kind of thing. I want to give you something tangible that you can hold on to. So it's not as clear cut, but it might just help you keep those ideas in your head. So we've got our initial state here for each age group. So that's our S0. So starting our initial state. So the number of female lizards in each age group after 1 year. So we're going to S of 1. So after 1 year. So we take our Leslie matrix in this sense, and we're going to multiply it by our initial state. Gives us this. If we wanted to then go to year 2, again, we take our Leslie matrix on the left and we multiply it by our previous year. So that would be the S of 1. Not our initial state anymore. If we want to move to S of 2, we have to do S of 1 to find after 2 years. Okay, so that's really important to keep clear in your head, is that we're not each time using our initial state. We go from the year prior to calculate the next year. So to find the number of female lizards in each age group after 12 years, we're going to use the rule. So that's where we would find for the S of 12, we're going to raise our Leslie matrix in this sense to the power of 12 because we're going after 12 years multiplied by our initial state to get how many lizards will be in each age category. Please have these written in your notes. Know how to use them and understand the difference between recurrence relationship and the rule. All right. Exam hack. Since Leslie matrices only include the number of females, if a question asks you to find the total population, multiply your answer by 2. Because remember, we're taking the big idea that half the population is female and half the population is male if it's not stated. So read questions really carefully. If it says total population and you're working with Leslie matrices, you're going to have to double it because Leslie's only deal with female population. Okay. We're using the recurrence relationship and the rule with the Leslie matrix. So we've got some data from a study of a 4-year lifespan of the fish population, and we've got our initial state and we've got our Leslie matrix here. So how do we know from the Leslie matrix that the fish don't breed until they're 2 years old? So the way we know is that if we look at this top row here, we know that we haven't got any birth rates for the age category from 0 to less than 1 and 1 to less than 2. So they're not actually birthing until they fall into this 2 to less than 3 years of age. So we haven't got any birth rates sitting in here. So the first 2 elements are 0, meaning that the fish up to 2 years have a birth rate of 0. So remember, this is our birth rates in this top row. So show a calculation using a recurrence relation to find the number of 2-year-old fish after 1 year. So we have to go our initial state. So we're going to find, we want the S of 1. So we want to go after 1 year. So we're going to do 1 iteration. So we're going our Leslie matrix multiplied by our initial state to give us after 1 year. We need to then read from that matrix and find the appropriate age group. So we are looking for 2-year-old fish. So that's sitting in here. So 2 to less than 3. So they would be 2 years old. So it's 122. But remember, it just wants to find the number of 2-year-old fish. Now, it's 122 female fish, okay, but it just wants fish overall, so we have to double it to represent the male population as well, meaning that there'll be 244. So again, really read your question because that is tricky. It doesn't just say, it just says number of 2-year-old fish. This would be the number of female 2-year-old fish. Read the question. Show a calculation using a recurrence relation to find the total number of fish after 2 years. Again, another one of those questions. When we get our first set of solutions, it is going to be female fish only. So we are going to use the matrix we found prior because we're going to go our Leslie matrix multiplied by the year prior to get the second year. Okay, so after 2 years. Then we are going to need to double each of these values to represent both the female and male populations and add them together. Can you see here too, we've rounded. So we've rounded this up after we've multiplied it because we have to represent that they're whole fish and not half fish. Okay. And we end up with the 10,453 fish after 2 years. In this instance, it's asking us to find the number of 3-year-old fish after 10 years. So we absolutely could work through all of the recurrence relationship calculations, but it's going to be a lot quicker for us to just use the rule. So we're going to jump to after 10 years, so S10. So we're going to raise our Leslie matrix to the power of 10 and multiply it by our initial state in this instance. It's just asked us to find the 3-year-old fish. So again, we're going to have to double the appropriate age group. So 3-year-old fish is this group here. So we are saying that there is 79.152 fish that are 3 to less than 4 that are female. So we're going to multiply it by 2 and then round. So always multiply it first. Don't round in your calculations, round your solution. So that means that there is going to be 158 fish that are 3 years old after 10 years. So long-term Leslie matrix trends. In the long term, populations modeled by Leslie matrices can increase, decrease, or cycle. So a cycle involves a repeating pattern of state matrices that start and end with the initial state matrix. So in the long term, the population modeled by M times M Leslie matrix L will increase if the population of SM is less than the total population, decrease if the total population of SM is less than the total population. I'm going to go through this so you can actually see what it looks like. It's a little bit confusing to just read it out of a table.